Okay, then let's start. My name is Sigmund Broja. I'm from Siemens, responsible for the Competence Center Integrated Engineering. With me,
Yeah, good morning. My name is Helgi Brettschneider, also with Siemens for a couple of years. We both have an engineering background by trade, I would say. So I'm a technical consultant, and I will do a short demo now on the disk use case.
perfect, Helga. We are not alone. We have a third guy with us. That's Michael. He's the product owner of the DISC and DEXP features that we presenting today. Okay.
Yeah, so in the end, you can blame him then, right?
Yes.
If it doesn't work out, right? No problem.
Okay, guys. Siemens. We are not this one who are delivering power plants or trains or fridges. We are from the digital industry, process automation sector, and we have there a new segment called PASW, software. That means all software products, not DCS systems, but all software applications that are dealing somehow with process industry are bundled in this new segment. And all in all, we have already, I would say, let me see. All in all, I would say we have already more than 25, 30 years experience in the process industry. And yeah, I think we know the needs of our customers very well and try to be always an open ecosystem. Really invited also others to be part of the journey. And yeah, that's really important for us to be not alone and to really collaborate also with other vendors. I mentioned we have bundled inside our software segment multiple products. If we are looking on this picture, we are starting very early in the product design with our simulation suite with GPROMs for the molecular design of products. And it's of course interesting for us in COMOS for engineering, for the feed engineering phase, for example, to reuse this data. And if I'm looking a little bit further, we are doing basic detail engineering COMOS. We are doing also with COMOS PCA first draft of automation software. It's interesting to simulate maybe very early the automation software with SIMIT. And here we are also talking about the exchange of process data. That means now we can think about to develop an interface several times or reuse a standard like DEXP. And we have, if we're looking on the whole picture, we always have this challenge. And we believe also in Siemens that we can reduce the amount of developments if we are focusing on industry specific standards. Okay. If we're looking on the whole life cycle phase of a process plant, starting with greenfield engineering, but then really a long phase of brownfield engineering, redesigns, upgrades inside the plants, they are happening every day. That means also changes in the documentation. And okay, that's bad for us, not always with our solutions. Very often EPCs, engineering partners, are involved using their own tool sets, and then the data handovers are always a challenge. That is also a reason why we are here. Why we think it's a very, very nice idea to have this community here to participate, because here is also the main topic really to be open and to communicate also with other authoring systems in the complete lifecycle phase. Okay, with these words, I Helge will take over for the presentation.
Without much further ado, right?
Okay.
No problem. So let's do that. Yeah. So that was that is the demo content now for my portion over here. So get a PNID in, get datasheet data in, merge that, so to say, show that you can search and query it, and potentially change it eventually, and get that out into a DXP format. So let's do this. In the end, Ziggy will come back and show you, let's say, a future development of an outlook on what we are, how we would like to use DXP as well. So he already said we committed as Siemens to use that not only externally but also internally to communicate amongst our tools. And but also how could we take that further? Yeah. So we were asked, hey, what could you do? Get some bonus points or credits on ideas how to evolve that potentially. So let's do that. So first thing is get the PNID in. So I've now loaded up our application. Comos over here is the engineering workbench. I will later also talk how to use the web front end. So this is more the heavy lifting application for changes. Since I'm supposed to do a change, I will open up the client application. Can also view and query and visualize data in the web front end, just to say that. So I now can open up a plugin to do an import. We have a little plugin over here. I can now select the folder from which I would like to import from. Created a small folder over here. So this is my sample PNID, the XML, the blueprint format. I can upload a bulk upload. I can do single uploads and do that now. Takes 30 seconds or something like that. So it's now creating objects in the database, as we call it. So the object in our database with object-centric is a digital representation of the engineering item, or in the life cycle later on also of the physical operated item. It's done now over here. So I got now my PNID over here. Well, which is a fail. Oh boy. So now you see that it is a live demonstration over here. Okay, let me do that once again. It was just working out fine. I'm not sure what happened here. Say yes, otherwise I need to pull up the video. Sorry for that. Yeah. I need to hurry up then. Oh boy. So what I said, we can blame Michael then later on. So this is my...
We really understand the risks doing live demos. So we really love you guys for actually taking that risk. So we will be patient.
Yeah, no. Thank you. So, Proteus is completed. Huh? Oh boy. Okay, then I need to fall back. Just what I did a couple of minutes ago. No, that should work out fine without internet. It's sunny. Close. I don't know what happened. So that was actually the way it's supposed to look like. Sorry for that. We'll see what we'll figure out what was the problem there, and then please come to our booth and we can redo that. Unfortunately, so that's the way it is supposed to look, right? After the import, just did that in half an hour ago or something like that. So what we do here is we create the items in the database. Yeah, so we have all the items created over here. I think the most important thing is that we also have the pipe objects created, which is the biggest benefit, I believe, with DEXB, that you have a suitable pipe model. Yeah, so we can create the objects, the graphics, but also the associated data. And now we need to come to the upload the data to the item. So what we did here, we mapped our class library that we have in Comos, not only to DEXB but also to the PCA attributes. Yeah, so we created PCA attributes with their identifier. We created different views to a single item, so we can have a functional view to the object. We can have a product view to the object. And what I will now do is upload data to this item through a text file. Yeah. So what we actually did here is we were not using, for the sake of that event here, we were not using the TTL format or the JSON format. We were using here an XML format. Yeah. So for that moment, the way it looks like is this, like this guy here. Yeah. So pretty. So JSON, as required, would require some additional configuration here to map to this particular format. But now, what I can do is I can now import data, so I can manipulate this XML file for the import. Just reload it once again to prevent further hiccups as well. So what I can now do is upload some data. In this case, I need to fill it out manually over here. Yeah, I've already typed in some values over here. Some technical data. Save that. And start the import. So when I open now my data sheet, my data, then I have my data view over here. So I've uploaded my technical data here. This is one view. I can now create a data sheet view as well. Yeah, that is another view, more suitable to the engineers. I can do an upload, or a different view could be a product type of data sheet. Same or similar data set, but then in a different style, in a different way. Yeah, again, all mapped to the PCA data so far. So we did that conceptually for the proof of concept, or for this event, not proof of concept. So I can query my data. So this is one type of visualization, yeah, data type, more suitable data sheet type. The data sheet layout can be adapted, can be made available through the web browser as well. So, and then I can query my data. So for instance, I want to search for that particular valve, and I have a searching engine over here, so maybe just search by its function. Yeah, then I can find that. It's now, since I have it as an object in the database, it's interactive. That means it creates kind of a logic. It's navigatable. Yeah, so I can search for tag IDs, for descriptions, for technical parameters. But I can also navigate now through the package. That means this object knows to which other objects it is connected to. Yeah, so I can query and navigate, let's say, from this guy over here to its connected items. Yeah, then I see here, okay, this is connected to a pipeline over here. Yeah, and as much. I can navigate, once I have the connectivity information in through the DEXB, I can navigate through the whole package. I can open up a query and query data. I'll save that for the moment. Yeah, query. This is an engineering. Yeah, since we are a data-centric system, I can create queries, so I can just by drag and drop define what I want to search for. In this case, navigate back, maybe search for all valves. Just by drag and drop, any user could create a query. So in this case, I'm searching for all valves. I can annotate and manipulate that and say, okay, show me all, let's say, design pressures and temperatures over here. So I can use that to bulk manipulate data. So that's more an engineering approach. That means I can now write data to these items as well in a query, in the bulk processing step. So that's around searching, querying, and manipulating data once they are in. Okay, so now it's about changing this information. We have already seen that one thing is to get data in. I can export and import data into most of the applications. I believe it's also important to understand the capability to track changes and see who has changed something and maybe why. So audit trailing or keeping track and keeping an overview about changes is important. There's no different ways we can do that. So first of all, I have a data set that I'm managing and want to manage for that valve here. But on the other hand, I have a data sheet, and that is an engineering artifact, and that also needs to be treated and managed and treated like a document and put under revision control. Because that is one means of keeping track of changes. And also one means to make sure that information are not changed without notification, without approval and acknowledgement. So therefore, I can put this document under revision control. That is a simple click here. Now, from that point onwards, I say, okay, I want to track my changes on this particular artifact over here. That means I have now created the first initial revision of a document, and now I will apply a change to this document through the import rather than just through the editing step over here. That means I can go back to my data sheet and now apply another change. Enter new things. Design pressure 0. Temperature at the right stage 16. So now do the import once again. And I will also track our, or let's say, auditing capabilities over here. So I do the upload once again. So what I got now here is when I open up my data sheet now, so I have now what did I change? What was changed through the second import of data or through the second change? Then I can see that over here, that I have here a little representation on the data sheet. First of all by this italic lettering, but also by this asterisk here, because we have a revision control not only on the data sheet, but also on the underlying data set. That means what COMOS does here is I have changed an approved revision of a document, although I have changed the data set, the underlying data set, and I can track that here now. And when I now create a new revision of that, so I'm actually asked to do a new revision of that data sheet, run it through the cycle once again. That's what I can do now here. And when I now open my data sheet once again, then you see that it's printed in here, this revision step now. So that's not only safeguarding the data set, but also the derived or derived data sheet, the engineering artifact. And if you now say, okay, if I now do that for hundreds of data sheets, how can I now keep track of that one? We can also switch on now an additional, let's say, visualization of changes over here. That means I have now a color coding here in the system. Yeah? Now that I was the guy who changed it, obviously easy to know what has been changed. But if there's now another person coming in and said, "Hey, what happened in the last week or during the last change period over here?" then I have now the capabilities to visualize these changes over here. So we have an indication. Light blue means something is changed in this plant breakdown structure underneath. Yeah, so I can see, okay, there is something underneath the pipe here. And I can actually find my valve over here, and I can see here this particular attributes have been changed through my latest change over here. Yeah. So, changing the data sheet. I have already done that now, right? Visualize changes. And visualize that, yeah. So the next step would be changing the pin ID and get that out as a DXP file. Yeah? And what we said here, because time was short to collaborate with any other vendor, we said, okay, use the verification tool for the moment, yeah, and show what has been, what's the outcome over there. So let's apply a change. So I was thinking, okay, just get a new valve in here. I can go now to my class library. Yeah, because our engineering workbench here relies on the class library. We have our own definitions, but obviously that can be mapped to client requirements and to DXP class definitions there as well. That's what we did in the preparation stage here. So I'll get another valve in here. Yeah, so that's what I can do now. So we just keep it simple over here, place things, delete things, change things from data changes, already shown that yet on the data sheet. So, and now I can export that. So therefore, we have an exporter as well. So what I can do here is I can export 1 to n pin IDs and write that into a DXP format. I can therefore create what we call a scope or a scope package. Yeah, I can package these documents or these exports, and then I can drag and drop my pin ID in here, and now start the export. I've defined for the demo an exchange folder in this case. So what it's now doing is it's taking now our file and writes that into an DXP compliant format. Yeah. So that takes probably a minute or something like that. So it's now collecting all the devices by its class definition, yeah, and creates the XML file. In the meantime, while it's doing that, probably takes a minute or so. Can give you quickly a glimpse on the web viewer. So what I was mentioning here, mentioning before actually, is that the web end or the web front end is available as well. That is typically for viewing, searching, viewing, querying information, just viewing it. Also do the annotation bit, yeah, because the change typically comes with an annotation as well. So we can also manage the pin ID as a document, also can create revisions, annotations on revisions, put them into workflows as well, yeah, similar to the datasheet. Track changes on the pin ID, and then have that visible and viewable through the web front end there as well. I like the idea of doing color coding and restructuring pin IDs as well. Ziggy will explain a little bit or elaborate on that one a little bit further, because that is one idea. Obviously, once you have a PID, you want to restructure it for specific purposes, do color coding and restructuring on commissioning, use it for automation purposes. That is what Ziggy will elaborate on. So now we got the export done. So I have now here my verification tool. And that is the one that I've just created over here. See, it's the timestamp here. Pardon? Let's hope that this one now comes up. And not also black boxes here. Oh man. Sorry for that. So in the end, I have to confess what we did is it's not 100% compliant to the format, so you will probably see that there is still some stuff that we need to do a mapping on. But we just thought, okay, let's show that, show the basic capabilities. What we would need to do is we would need to map our data model a little bit more to the DXP export to be compliant to that particular format over here. But basically you see that the change is applied and it is written and available over here in the DXP format. Okay, so much for the workflow that was asked for. We said, okay, one thing was, what can you do with PDF? There was a requirement actually coming from you guys to turn DXP to turn PDF and dump data into DXP compliant PIDs through some magic, I would say. What we did, we are working on that one. We have to say that we are not yet ready yet to show that here in an audience like that. Therefore, we just decided, okay, we also have capabilities to, let's see, retrieve at least some intelligence from scanned and PDF PIDs or PDF schematics in general. Therefore, we said, okay, let's show and how we call it an hotspotter tool. Yeah. Is it working? Oh yeah, okay. So we just took another PID in a PDF format, loaded that into our application, and what we can do in the loading step. So again, it is treated partially as a document. So COMOS is an engineering document management system. That means we take engineering or treat engineering artifacts like documents, but we manage the underlying data sets. And what we do here in the loading step is that we retrieve some intelligence from the PID. So we can define searching patterns. For instance, search for specific tag IDs. We can also consider specific formats, like for instance, when you have line breaks in an instrument bubble, for instance, and you need to concatenate things from different text blocks, then there is some intelligence provided here. So I can define my searching patterns. I can also define, hey, search around something around that instrument bubble for here. For instance, takes a D-38 and the EXSV and concatenates that. So it can create tag information from individual artifacts. So it's more than just searching for text blocks. And then it can actually do some hotspotting over here. So what I can do is I treat it as a document. I have some graphics representation on the PID, but I also retrieved information and I can link it to our COMOS objects and have at least some navigation and exchange capabilities over here. It's not a smart DXP PID. I cannot manipulate that drawing. In case I want to change it, I need to change the originating cat file, typically still is, right? And do an upload of the changed PDF and do a reload. This tool will realize that it has already been uploaded and there is now changes and items are already linked. So it will only show you what has been deleted, what is new, and maybe changed. So it's providing and supporting that engineering work step, but still not an let's say creating an intelligent DXP file. We are working on that one. So we have a group right now working, we call that IDAMA, Artificial Intelligence Data Management. Yeah, and these guys have the task to develop, to use artificial intelligence routines to create a DEXP P&ID from a PDF or text or document hard copy scan, so to say. Yeah, maybe in one of the feature sessions over here. So, Ziggy, then maybe this is now, let's say, what we are delivering today. Ziggy now will give you a few words around how we want to use DEXP formats, in particular in the automation area. And there where we have an, let's say, an initiative or a tool, let's say a development called Requirement Module Type Packages, RMTP. Ziggy.
Okay, thank you, Helga. Yeah, now we are moving a little bit in automation. But nevertheless, the idea was how we can reuse maybe DEXP data for other use cases. Yeah, and here we are talking about module type packages. We are talking about modular plant design, and if we are talking about modular plant design, we are also talking about modular automation. Yeah, and I don't know if maybe some of you already heard about the MTP standard. It's a developing standard driven by Namur, now by the ZVEI in Germany. There are also not only Siemens, maybe all DCS vendors are already part of this community. And the big target is to develop a standard, non-proprietary, for automation software, for specific own controlled process modules. And the idea is behind that, okay, if something needs to be exchanged in a process plant, you don't have to wait maybe some weeks because DCS software needs to be adapted because you bought maybe a system not from Siemens, you bought something from ABB, and then it's not fits together, but with MTP technology, you can be very fast again in production. Yeah. And our idea, okay, was how we can contribute to this idea with Comos. And yeah, we have prepared a small video for you where we are creating some plant engineering with Comos, but we are exporting DEXP. That means the plant engineering can come from any other vendor. Yeah. And we are enhancing then this information for the requirement description, what capabilities a process model should have from the perspective of an automation view. Okay. Then I hope maybe.
Hello all. Welcome to short demonstration of modular plant automation configurator cloud-based application. Let's see main use case of this application. In the process engineering phase, all data created and configured in plant engineering software. For automation engineering, functional description data will be manually created and documented in the form of big Word or Excel files. This data also not tightly integrated with process engineering software. To overcome this manual step, we have built this cloud-based application. Let's see the functional overview of our application. The workflow will start with plant engineering software. All the process data already configured in this software. This data will be exported in the form of standardized Proteus format. The next step will be importing this data in our application and carry out certain steps like visualization of data in the form of P and ID, creation of MTP objects like process equipment assembly, services, procedures, control modules, etc. Establish relation between MTP objects with P and ID objects. Generation of requirement MTP file. This file will be consumed in automation software where detailed automation engineering steps will be carried out and fully configured MTP file will be generated. Current targeted use cases for this application are reuse of already available process data to reduce manual efforts. Standardize and digitalized generation of function description for automation. Input data can come from any plant engineering software in standard Proteus format. With this short overview, we would like to show you short demonstration of our application. For demonstration purpose, we have taken example of premix tank section of flavored milk plant. This premix tank section will be divided into two operations, filling operation and mixing operation. Filling operation will have three procedures. First, flavored milk with sugar where all three filling lines will be used. Second, sweet milk where raw milk and sugar solution line will be used only. And last, flavored milk without sugar where raw milk and flavor agent line will be used. Mixing operation which will be manual and time-based. Let's see how this example will be realized in our application. As mentioned earlier, our workflow is started from Comos application, where example P and ID is already created. All the required process data is also filled like measuring range for pressure transmitter and for temperature transmitter as 0 to 55 degrees Celsius. This data is exported in the form of Proteus file. This is our application UI, where we import this data in the form of zip file. After successful import, when we start project configuration, imported data will be visualized in the form of P and ID and plant breakdown structure. If we see details of pressure transmitter, all the configured data is also available in our application. As a next step, we will start creating MTP objects. We will create process equipment assembly object, and under that, we will create our first service object for filling operation. Now we will assign P and ID objects to filling service to establish relation between physical and MTP nodes. We will select objects from all filling lines and level transmitter from P and ID and assign them to filling service. Similarly, we have created another service for mixing operation and assigned P and ID object to it. By selecting each service node, P and ID objects will be highlighted in given color for proper identification. We have already created procedure objects as explained earlier and associated parameters required for those procedures. Now, let's create control modules. Control module is a collection of sensors, actuators, and associated processing equipment which is operated as a single entity. Next, we will assign P and ID objects to these control modules so that process data which is available in P and ID objects can be transferred to control modules. Next step is to assign MTP library types to these control modules. Once we do that, we can see the process data gets transferred to parameters of control modules. This will save manual efforts to add these values one by one. Now we will see how we can establish relation between procedures, required control modules, and parameters. When we go into details section of service object, we can establish this relation in the form of procedure matrix. For the first procedure, which is flavored milk with sugar, we required all filling line. So we will select all control modules placed on these lines. Since we required flavor also for this product, we will select flavor selection parameter. This is how procedure matrix will look like once we define for all procedures under filling service. Similarly, we have defined procedure matrix for mixing service. Once we complete all this configuration, we will export this configuration in the form of MTP file. Generated MTP file will be stored in cloud, and user can download this file in his local machine. Let's see how exported configuration looked in MTP format. As per the configuration, we can see filling and mixing service in service section. All created procedures are available under service object, and all the linked control modules and parameters appeared under each procedure. That's it from our side. As discussed earlier, this file will be consumed by automation software for further processing. Thank you so much, and feel free to give your valuable feedbacks or suggestion to us. Hello all.
That's our task here. Yeah, I like the idea because we had that topic, I believe, to restructure an information, right? Also to take a PNID and turn that, we do it now and turn it into associate or allocate, let's say, PNID lines and systems to automation and control modules. But of course, you can do similar things to, turn it, allocate it to commissioning systems or subsystems.
And it fits also very well to ideas like asset administration shells, for example, that we are handling really data only by delivered standards. Okay, Michael?
Yeah, just to take the blame for Helge's presentation. You could visit us as in the booth to verify
Too late.
software works a bit.
Too late.
Yes,
But the first time.
responsibility. Thank you so far.
No, but I think the first time that we were on time here, really, on to the second. Thank you.
Thank you.
Thank you so much, Siemens. No doubt that you've been in this game for many, many years, all the way from Germany. You have come here to join us, and you have been really eager in this collaboration towards this event. So I know that this means a lot to you. Thank you so much. Any comments from the technical committee?
Yes, I think we saw a thorough demonstration, handling the data as we were kind of indicating. Traditional ways, handling the PDFs, handling the DEXP structure that we shared. So I think they are scoring or ticking my box in quite a few of the areas. So thank you very much.
Thank you. Big applause.